Assalamu alaikum, dear students. Last time we talked about the building blocks of life. This is one of the topic of your syllabus course outline that is mentioned above in this slide. That's why we will talk about the chemical basis of animal life. Chemical basis of animal, plant, or all the biological life, that is almost the same. That's why the title of the presentation is building blocks of life. In this topic we will talk about what are atoms, elements, which are the building blocks of all matter, the compounds, molecule, aggregates of atoms, acids, bases, and buffers. In next lecture we will talk about the further lectures. Those are the molecules of animals, fractional accounts of carbohydrates, lipids, and etc. etc. We will talk about the basic terms and the structure, the role in structure of molecules, variation in physical properties, how the change in the structure, it changes the variation in, it brings the variations in physical properties, how molecules are organized in different structures. Molecular structures found in life are called biomolecules or macromolecules. Basic composition of proteins through simple physical properties, basic formulas of carbohydrates, and a few other structures will be discussed in later sections. Atoms are the building blocks of all the matter. That is the one of the core structure. There is the figure for the structure of abundant isotopes of carbon. See 12, 13, and 14, and how many electrons, protons, and neutrons are there. That is written there, and you all must be familiar with this. Electrons, orbitals. What are the orbitals or electron orbitals in an atom? This is the electron shell diagram, where nucleus is in the center and there are different various electron orbitals around the nucleus, and those electrons are revolving in those orbitals. Energy levels. These electron orbitals are of different energy levels. You can see in the nucleus is in the center, and it's at low energy level, and energy of the atom, it increases, or of the electron, it increases as we move outward from the nucleus towards K, L, M, or N shells. There are basic reactions occurring in any atom. They are type of oxidation or reduction reactions. Carbon loses hydrogen, therefore it is oxidized. This structure, this one, it is being oxidized because electron is being removed, and where the electron is added, this structure is being reduced. Electronegativities, that is another aspect of all the atoms. This is the periodic table. This is containing all the atoms of the existing so far. These are the electropositive atoms, and these are the mostly the metals, alkali metals and alkaline earth metals, and these are the electronegative end of the electronegative atoms of the periodic table. We will see what in the biochemistry there are several different types of bonds that are important to understand for biology. Covalent bonds, where the electrons are shared. Ionic, where there is transfer or swap of electrons. Polar covalent, which is somewhere in between, not fully covalent, not fully ionic, but partially ionic or partially covalent. The reality is that most bonds have both ionic and covalent characteristics. They're polar. There are different types of bonds, names of the bonds, and the basis of interaction, and the strength, either it's strong or weak. Covalent bond, it happens as a result of sharing of electrons. That is why it is strong. Ionic bond, it appears as a result of attraction of opposite charges. It's also strong but less strong than covalent bond. Hydrogen bond comes in between, then comes hydrophobic interactions, and at last van der Waals interactions, which are weaker. Ionic bonds, you see there is the formation of sodium chloride is mentioned there. Sodium has one electron in the outer shell, so its electronegativity is very small, so it's more electropositive. Electropositive metals, they can lose their electrons to more electronegative atoms, and that's why the ionic bond formation happens, and in this, as a result, NaCl crystals are produced. Covalent bond. Covalent bond is mostly found in alike atoms. You see, there are three types of atoms: hydrogen, oxygen, and nitrogens. And covalent bond is formed by the mutual sharing of electrons between two atoms. You see, there are two electrons are shared between hydrogen atoms, one from each atom. Two electrons are shared, one from each atom, and two covalent bonds or double covalent bond is formed here. In case of nitrogen, three electrons are shared from each atom and three covalent bonds are formed within each atom. Electronegativity symbol is the chemical property that describes the ability of an atom, or more rarely a functional group, to attract electrons or electron density towards itself in a covalent bond. Electronegativity is also familiar to the reduction capacity of any of the atom. For example, oxygen atom, its electronegativity is 3.5. It can attract electrons more effectively among all these atoms. Then comes for nitrogen, for carbon is 2.5, and for hydrogen it is very low, it's 2.1. It is more electropositive. Bond strength. While it takes more energy to break ionic bonds in a dry environment, in living things molecules are in aqueous environment. Ionic bonds, sodium chloride crystal. It's not easy to break sodium chloride crystal when it is in the dry form. You need to put some energy or force on it. But when you pour the sodium chloride crystal in water, in aqueous media, it dissolves very easily. So therefore, in biology, covalent bonds are stronger than ionic bonds, and hydrogen bonds are weaker than both. And also keep in mind that in large numbers, hydrogen bonds can be strong, because hydrogen bonding is a lot in the water phase, in aqueous phase. Therefore, the net effect of the hydrogen bonding is very strong. Polar covalent bonds. Because oxygen has an electronegativity value of 3.444 and hydrogen has a value of 2.1, the difference is significant enough that at any given time the electrons are more likely to be found closer to the oxygen, because it is oxygen is electron attractor. Oxygen is well now electron thief. While there is no official charge on either atom, we have a partial charge, partial positive and partial negative. Partial positive at the hydrogen end and partial negative at the oxygen end. According to Bohr formula, you see there are kind of two hydrogen and oxygens there, and water molecule. You see this is kind of a covalent bond with the hydrogen oxygen, and oxygen is supposed to carry partial negative charge and hydrogen carries partial positive charge due to the formation of poles of electrons. Hydrogen bonds, because hydrogen has such a low electronegativity value, when it is bonded to something with a strong value, the polarization allows the partial positive charge of the hydrogen to form a weak bond with the partial negative charge of another polar molecule. That is actually the foundation of the hydrogen bonding formation. Which elements bonded with hydrogen will help to form hydrogen bonds? Let's see. Here you go. There is water molecule with red ball as the oxygen and two small balls as hydrogen atoms carrying partial positive charge. These partially positive charged hydrogen, but each one of them is having ability to interact with the partial negative charge carrying oxygen of another water molecule. So this kind of formation is called hydrogen bond formation. and it happens abundantly in aqueous phase. It's the same structure written in detail. Water, therefore, a single water molecule can form up to 4 hydrogen bonds with other molecules at a time, and when combined with other water molecules that can make 4 of their own hydrogen bonds, the net strength of those bonds is thus very significant. Here you go. There is one water molecule in the center. This oxygen is making hydrogen bond with the hydrogen of another molecule, and this hydrogen is making hydrogen bond with oxygen of the molecule, that is carrying partial negative charge. Similarly, the oxygen is again connected to hydrogen through hydrogen bond with the oxygen with the hydrogen molecule of another molecule, and similarly for two hydrogens there is hydrogen bonding, and for oxygen there are two hydrogen bonds. Water phase changes. When going from a liquid to a gas, hydrogen bonds have to be broken. It requires an increase in energy. We need to give it energy. We need to heat the water to get it boiled, because we need to break the hydrogen bonding with the water molecules. When water evaporates, it takes energy from the environment, which in turn cools off the environment. Sweating cools us. When water freezes, it is releasing energy to the environment. When we keep water in the fridge, we need to extract amount of energy to get it freeze. Solutions. What is the purpose of the solution? Ions dissociate in water. Covalent molecules that form hydrogen bonds with each other can break the hydrogen bonds and separate into individual molecules. Dissolving sugar in water, it separates the individual molecules, break the hydrogen bond. Each sucrose molecule gets surrounded and shielded by water molecules. That's how the things get dissolved. Water is the best solvent. This is the solvation process of sodium chloride, hydrogen bonding, hydrogen cells, and each of the sodium ion and chloride ion that is being trapped by the water molecules all around. These are a few of the properties of water that is very important to life. Its first property is cohesion. Hydrogen bonds hold water molecules together. Leaves pull water upward from the roots. Seeds swell and germinate. That's the benefit. High specific heat. Hydrogen bonds absorb heat when they break and release heat when they form, minimizing temperature changes. That's how water stabilizes the temperature of organisms and the environment. Next is high heat of vaporization. Many hydrogen bonds must be broken for water to evaporate. Evaporation of water cools body surfaces. Low density of ice. Water molecules in an ice crystal are spaced relatively far apart because of hydrogen bonding. Because ice is less dense than water, lakes don't freeze solid, allowing fish and other life in lakes to survive the winter. Solubility. Polar water molecules are attracted to ions and polar compounds, making them soluble. Many kinds of molecules can move freely in cells, permitting a diverse array of chemical reactions. These are all the benefits or advantages of water to the life on the universe. An example of water having special properties in action is all written here due to the property of cohesion, solubility, etc. Other weak intermolecular forces, they come due to the van der Waals interactions, due to symmetrical distribution and due to unsymmetrical distribution, due to partial positive, slightly less partial positive, or slightly higher partial positive, and interaction with the negative ends between poles, different poles. This is kind of a weak intermolecular forces. These are van der Waals interactions or London forces. Then comes the concept of pH. We will talk about this in the next slide.